So now we will have a look on how we can evaluate our model. We have learned a lot of measures like precision, recall, F1 score, area under curve score for the uh, models like a logistic regressor in which there can be multiple precision and recall scores against multiple thresholds. So we have learned area under curve, ROC, area under curve score also. Okay, so we will use that measures to evaluate our model. And here we have figured out in the start of model building that false negatives, we should be more sensitive towards the false negatives, and our recall score should be more high as compared to other scores. So here the function that I am using here, it's a very simple function. Here we can pass a model, independent variables, dependent variable, and we can also pass the threshold at which threshold we want to see the scores. By default it is 0.5, and if there will be another threshold, then there will be predictions will be according to the given threshold. Okay, so accuracy, recall, precision, F1 score, and all of that scores in the form of data frame. And this function will return a data frame having these scores like here. So in our case, that model we have trained till now, if we will pass our testing data set, testing data points, it is giving us the score. F1 score not good, 0.1. It's not good. Precision is very good here. 100% precision is here. Recall is very bad, 0.06, which is very bad. About 6% recall is here. Accuracy is quite good, 71, but it's not. We are more interested towards the recall. We want less number of false negatives. So here recall is very bad. We should have such type of threshold which can improve our recall score. Okay, so according to confusion matrix, if we will see here, this is the confusion matrix. These are the negative predictions by the model, and these are the false negatives, and these are the true negatives. These are the positive predictions by our model. These are the true positives, and these are the false positives. Okay, positive but false. Okay, here you can say false negatives are allowed 85 samples that are the false negatives, and there is zero here in the false positive. That's why precision is very high, recall is very low. So we should tweak our threshold for the sake of getting higher recall. Okay, here area under curve score is 69, 0.69. On the training data set, on the test data set, it is about 63%. Okay, area under curve score, which is again not good, not much good. These scores are, but here we have in that case we have already we have trained logistic regression on. We have logistic regression with best parameter values. We have we have data set, and we also have we have transferred our categorical columns into continuous some numerical columns. uh, this less score now can be due to less strength of our independent variables with the dependent variable. Okay, so this can be due to that. For that purpose, we can have some sort of other, we should consider some, if we want to improve that ROC, area under curve score, then maybe we should refer some more attributes. We will ask to our banks team that we should they should give us more attributes, more columns that we can use here, that have strong relation with our target column, with our prediction, with our risk. Okay, but here our model is giving area under curve scores 0.69 in case of training data set, and in case of testing data is less than the score, giving less score as compared to training data set, which is 0.63 here. Okay, so now we will have to set the threshold, as there is not mentioned how much recall we want here in the problem statement. So we will go towards the optimal threshold. Okay, so we will find out the multiple threshold, multiple recalls and precision, again different thresholds by using precision recall curve. And here we have plotted precision recall curve by using that function, in which two line plots here. Okay, by using that function here, we can see that our as our threshold is increasing, our precision is blue one is precision line, is increasing and orange is recall is decreasing here. And about when the threshold is near to 0.5, about 0.48, our precision will become 1 and remain as 1, but our recall is continuous decreasing with the increase of threshold. Here we will plot a F1 score, okay, F1 versus threshold score. So here you can see this is the curve, and we want such a threshold which is giving highest F1 score. Okay, so optimal threshold we want where the F1 score is maximum. So here it is showing us that maximum F1 score, which is 0.5, 1 is at the threshold of 0.29 approximately. Okay, so at this 0.29 we have maximum F1 score, and if we will see our model's performance when we have 0.29 threshold, then recall is improved a lot, 0.8 to about 82% recall our model have now. 0.3 precision decreases a lot, but it's okay because we are more curious about the recall, we are more sensitive about the false negatives. uh, F1 score is also increased and accuracy is decreased here. Okay, if I want to see the predictions that can be done when threshold is 0.29, that then you can see from here. In the case of confusion matrix, we can have a clear look like here false negatives are decreased a lot from about 88 to decrease to 15, and but here false positive increase a lot from previously we were having zero false positive, now we have 133. Okay, but we are more sensitive towards that. If false positive increase, then we will lose our potential customers, and if false negatives will increase, then we will lose our resources. Okay, so we are more curious about the loss of resources. So additional, it is just if you want to set the threshold according to the requirement, according to the mentioned requirement that recall should be 90%, then you can also set the threshold according to the to your requirement, that you want such a threshold that will give you 90% recall. You can also get, but here it's not requirement, so we should stick on that optimal threshold that we have calculated here. Okay, this one, this is our optimal threshold in our case, and it is just additional so that uh, it can be a revision for you how to set the uh, threshold according to our requirement. If our requirement will be uh, if our requirement was given as a 0.9 in our problem statement or 90% recall, then we can also set the threshold which will be 0.26, and here these are the scores. And confusion matrix has recall is increased from 80% to 90% by decreasing the threshold 0.26. So here our true negatives are decreased again from 15 to 9. Okay, in this way, as recall is increasing, true negatives are decreasing here. Okay, so till now we have seen how we can evaluate model hour. You already have learned these evaluation metrics, recall precision and F1 score, the other area under curve score, precision recall score. Here we have not used here. Uh, as it's up to you, you can use precision recall score, but you can use one of them, precision recall area under precision recall curve score, area under curve ROC score. Okay, you can use one of them, it's up to you. Uh, okay, but usually in case of imbalanced data, we prefer the score precision uh, score under the precision recall curve, but it's really not matter if you remain on you are using just one score, because you are just doing comparison, you are not using that score to display on some uh, to display it as a to your team or to your you can say other board of that dealing with the banks board. Okay, so you are here using area underscore score for the sake of comparing your models. Anyhow, in this way we can done the models performance. Okay, now we will see what are the important features by using a forward feature selection that we also have learned in the last case study of linear regression, how it works. We will use forward feature selection, and we will see what are the important uh, features in out of 21 independent features, what are the most important features that are that can be used, that are more important as compared to other features? Okay.